and the glare is larger.
Actual
Have you tried to
What's
do
the back
that?
zoom
I'm positive. Okay, we are recording now, so we're going to start the lesson. So this is definite integrals and antiderivatives. So what we're going to start with are some integration rules. I know, you're so excited.
Rule 4. Okay, you're not enough there.
I know that's a lot.
But it wasn't a free day, so
4?
What?
I don't
Can we
know.
just, like,
It should be rules. I
Can we
feel
write
like
one line
rules
of notes every
of
day?
definite integrals would be better than rules for definite.
I wrote it.
The first one is called order of integration.
I know.
So
I've had rules of.
when I talk about integrating, we always read from bottom to top for the interval. So this is the integral from a to b of the function f of x dx. If I were to flip the order of my interval, I must also change the positivity of my integral. So this would be equal to the negative integral from b to a of that same function f of x dx. So if I change the order, I also have to change the positivity.
So it reads from bottom to top, right?
Bottom to top, yes. So I flipped the order of my integral, so I changed the positivity by putting a negative.
Integral. I don't like that word.
I do, it's fun. Second one is the zero integral. This integral has an interval from the same number to the same number. So for this example, we have the integral from a to a. If there is no change in that interval, the area under it cannot be calculated, so it's just equal to 0.
What?
So an integral from a to a, so literally no change in my x values or in my domain, then my integral or area under the curve is 0, because I didn't move my x value at all, so there's no area to calculate.
Would that be our entire homework?
The third rule is our constant multiple. If I'm taking the integral from a to b of some constant times my function f of x dx, that is the same as pulling that constant out front and multiplying it by the integral of the function on the interval a to b. So if there's a constant on the very front of my function, I can pull it out in front of my integral, which means I don't have to use it in the integral itself.
Why is the constant like a?
Because c is going to be something different now. This also applies if I have a negative inside of my integral. So if I'm taking the integral from a to b of a function negative f of x dx, that is the same as pulling that negative out front. And then taking the integral from a to b of f of x dx, because that negative acts like a constant. Why do I have one random one?
All of them are the same.
Oh, I had to steal that one from another room. I didn't have any tests in here for my previous class.
Which is?
Okay, so that was rule number 3. We have some more. Rule number 4 is our sum and difference rule. So this rule says if I have an integral from a to b of two functions either being added or subtracted to each other, I can split that up into two integrals, either adding or subtracting them depending on what operation I'm adding. So my sum and difference rule says if I'm taking the integral from a to b of f of x plus g of x together, I can separate that into two integrals and then add their answers together. So that would separate into the integral from a to b of f of x dx plus the integral from a to b of g of x dx. So they use the same integral, I just split it into two.
You're gonna give examples of all these, right?
Of course. And then we have one more, and that is our additivity rule.
Not a word.
It's here. And this says, if I'm taking an integral from a to b of f of x dx and adding to it the integral from b to c of that same function f of x dx, that can be rewritten as one integral going from a to c of f of x dx. Well, you would think, but it still needs to be written. In math, we write everything whether it's common sense or
Leah.
not.
I'm not. I would not have put that together.
So those are our 5 rules that we're going to use in these following examples.
Yay.
Woo.
That's a lot. How long are these numbers?
Well,
Long?
the 2 days for a reason.
No, they're not. It's not
2 pages front and back.
No,
That's not a lot.
No,
It's really not.
We probably already did like a page and a half.
We've done half a page already, so we're an
I know,
eighth
I'm
of the
just
way
saying you
through.
write really big.
Oh, I do. Okay,
Go through a whole page. I used about 4 pages.
I used to love
Yeah,
mine.
whole pages.
I used to buy my job.
This much of a page, that's how much
That's not. You did not write a whole thing.
are we ready for some examples?
yeah.
Yay! So for these next few examples, specifically the next 6, we're going to make a few assumptions. The first one is supposing that f and g are continuous functions. And that the integral from 1 to 2 of f of x dx is equal to -4. The integral from 1 to 5 of f of x dx is equal to 6. And the integral from 1 to 5 of g of x dx is equal to 8.
So I thought you said you were gonna tell us why we had to write E.
We will when we get to antiderivative.
Oh, okay, that's like tomorrow.
We should get to it today, hopefully.
So no homework today, right?
Nope, there's homework.
Why?
But we're doing it in class together tomorrow also. It's due Monday.
Please.
It's due Monday.
Okay, so the first one we're going to practice finding is the integral from 2 to 2 of g of x dx. So what I'm going to be using is the 3 integrals that I have already been given for this problem. Erin, why did you know that that's 0?
Genius.
Because the rule of the A to A.
Okay, so if my starting x value and my ending x value are the same on my integral, I didn't move at all, which means there's no area to calculate. So she is correct, this one is equal to 0 because my integral did not have a domain change. Do we all see how that's true?
Yes.
Yeah, but is that for
It doesn't matter what integral we're working
So
with.
even if
No,
you would have
like-
wrote,
so the green is what we're solving for.
The green is the information we've been given.
Oh,
This is what we're solving for. Yeah, so that's information that we have.
so even if you would have wrote like 2 to 2 and then like all kinds of stuff and like plus.
It does
minus,
not matter.
All that,
That's a
Just 0.
wonderful trick question for a quiz or a test. Just so you're aware.
kind of like when you do everything times like 0.
Okay, so I'm actually going to erase this one and write the next one so we keep that information at the top. So our next problem,
How much space do you gonna take up right now? It's funny.
is the integral from 5 to 1 of g of x dx. Yes, the integral from 5 to 1 of g of x dx. And I can only solve this using the information that I was provided, which are the 3 green integrals. Do I have an integral that goes from 5 to 1 in those 3 pieces of information?
Is it negative?
Hold on. No, but I do have one that goes from what to what?
1 to 5.
1 to 5, and is the function g of x dx. So I have a rule that says if I flip my integral order, what do I have to do to the function? Put a negative out front. So this becomes a negative of the integral from 1 to 5 of g of x dx by the rules that we wrote down. And I know the integral from 1 to 5 of g of x dx. It's equal to 8. So my answer here is going to be negative of that integral, which makes it negative 8.
Didn't you just say no to that?
No, I said,
You definitely said no.
She said no.
well, it's because I didn't want you to answer it yet.
She
Like,
said
I
no
thought that
as
was
until
right,
when?
and I thought it was
No, it is negative 8, yes.
And then you said no to Devin, so I was like, alright, I know what it was.
It's
Yes.
no as in.
I don't know why it's negative. Like I couldn't picture on the graph like 5.
Well, no. Well, I'm flipping. Oh, never mind. We'll get there.
We're flipping a whole bunch of stuff that you don't know yet.
Okay. Questions, concerns, or issues with how we solved that one? Do we see how the rule applied?
Yeah.
Okay, so let's try another one. So this one is example C. I am going, or trying to find the integral from 1 to 2 of 3 times f of x dx.
Whoa.
Do I have an integral that goes from 1 to 2 that is 3 times f of x dx?
No.
No, but I know what I can do with a constant being multiplied into a function. What do I do with it?
Put it in the front.
Put it in the front of my integral. So this becomes 3 times the integral from 1 to 2 of f of x dx. Do I know what the integral from 1 to 2 of f of x dx is equal to?
Negative 4.
Yep, it says right here. Negative 4, so it'll be 3 times negative 4, which is negative 12.
This is easy. Oh, is this gonna be a
So
hard?
I'm guessing we won't always have like that, like finding
Where are
it
you
around.
guys?
So.
I need my calculator.
Okay, are we feeling okay with these so far?
Yeah, but I
Okay.
know it's gonna get worse.
So let's do another one.
Let's just keep the best one.
So wait, you're still keeping those things at the top.
Yes, we're still building off of that.
Yeah, I know.
Build it.
It took me a little while.
So do you.
I lost it.
I would like the integral, stop talking please, from 2 to 5 of f of x dx.
I don't like that, but I also do like this 10.
Do I have an integral that goes from 2 to 5 for the function f of x?
No.
No, so I'm gonna have to use what I have to build that interval. What information do I have though about f of x dx? What have I been given?
You have 1 to 2 and 1 to 5.
Right, so if we were thinking about this as just general math, I could take
Subtract.
1 to 5 and subtract from it the area from 1 to 2, right? Because that would just leave the area from 2 to 5.
What?
So
No,
this
we're
is going to be the integral from 1 to 2 of f of x dx. So that total area on my number line from 1 to 5.
1 to 2 or 1 to 5?
Hold on.
You wrote 1 to 5, but you said 1 to 2.
Okay, 1 to 5. We're doing 1 to 5 first. Because I want this total area. And then I'm going to subtract from it the area from 1 to 2. Because then I'm taking this portion out, which just leaves the area from 2 to 5, which is what I wanted.
Wait, but in the rules it says, never mind.
It works for addition and subtraction.
Yeah,
So we just did it backwards. Do we all see how I did that and why that was okay? Okay, so then we just fill in the integral information that I've been given. So what is the integral from 1 to 5 of f of x dx equal to? 6. Minus, what's the integral from 1 to 2 for f? Minus a negative 4, because it says negative 4, which means that becomes 6 plus 4, which is 10.
Alright, done.
Give
me the homework.
How we feel?
Sure.
Let's do another one. We have two more that relate to this example.
How big room are they gonna take? There's one example taking about
These two.
It's like a line.
Pretty much.
This is this
It's the
one.
same information.
Is that one of them?
You're gonna need 6 notebooks by the time we're done.
I've only
She has
used one.
that
3/4
one
of a page in
part.
that one line. It's only one line.
Hey, it's her. It's okay.
Her zero took up like 5
It
lines.
didn't take me a moment. It took me this.
Wait, did you make a 0 and then circle a 0?
No, it's dead.
So like 5, 6 lines tall.
Okay, so now for this example, I would like the integral from 1 to 5 of f of x minus g of x. I know I don't have that information, but is there any way I can separate this into two integrals?
We have that.
Could you just do fx dx minus gx dx?
Right. So I would separate this into two integrals, each going from 1 to 5. One of them will be f of x dx, the other will be g of x dx. And I will follow the same order it's written here. So it will be the integral of f of x minus the integral with g of x.
So 6 minus.
Hold on, we're not there yet.
Simply that's just kind of common sense. It's
We
split it
still
up.
have to write them, yes, I
Do
know.
have to?
No, you guys are okay, but I will always write all the like steps in case there's any confusion. So what is my integral from 1 to 5 for f?
6.
What is my integral from 1 to 5 for g?
8.
What's 6 minus 8? So the total area for f minus g on that integral is -2.
Now, isn't it in? Never mind.
How many lines did that take? What the?
She can read those.
I can read mine completely
I thought I was writing mine huge.
You just got back from like you just put down for all of it. And how many notebooks do you go through a year?
Per class.
There's no way.
Wait, could you also tear paper out of that, don't you?
No.
Or just put it in?
There's no 70 pages?
Because there's 70 pages or like 70 pieces of paper out there.
Okay, focus. Now I would like the integral from 1 to 5 of 4 times f of x minus g of x on this interval 1 to 5. So this one's gonna be 2 rules in 1.
Channel.
What's the first rule that I know I can do with this?
To put the 4 in front.
Nope, not yet. I can't do that.
Break it apart.
Split them up.
Break it apart. So I can't move the 4 out front because it only applies to the f. So I have to have the f alone before I can separate that. So this separates into the integral from 1 to 5 of 4 times f of x dx minus the integral from 1 to 5 of g of x dx. Deanna, what can I do with that 4 now?
Put them in the front.
So this becomes 4 times the integral from 1 to 5 of f of x dx minus the integral from 1 to 5 of g of x dx. And then I fill in the information that I have. I just moved it up. Questions, concerns, or issues on this one?
Wait, why did?
What?
All right. You know, I'm just gonna point this out. If Emily was here, she'd be looking at me.
You know, when she watches this video, she's gonna hear you say that.
And she'll text me, you're right. Here's another, because both of you two, as soon as she goes back and watches the video.
Woo!
Is that all? It's all these are- these are-
Questions, concerns, or issues on any of the 6 examples we just did?
Is there more examples?
Well, of course.
How
Not
many?
based off of that.
How many?
Hold on. Are there any questions, concerns, or issues on anything that we just did?
No.
Do we feel awesome and confident about this?
Yay.
Okay, let's do another one.
She said, okay, now I'm gonna ruin it.
How many examples are exploring with this one?
With this one,
Fine.
just one.
Oh, that's cool.
like you didn't have to add all those words.
No, you really didn't have to write any of that. Piecewise, more like piece dies.
I think we should just upload our math class conversations on YouTube, and we'd probably get a lot of views.
Probably.
We're gonna find out what we're talking about.
So I'm gonna move this down so everybody online can, I'm gonna put it back up. So you guys can pause it if you need, so you can write it. In case they watch it, I need to be prepared. Also, I might save these videos for next school year.
Oh, they're gonna like that.
You could just sit at your desk all day.
And just
every day,
play,
and
no,
play
I
the
meant
game.
like, in case anybody misses class, I need to go back and watch it.
They're gonna be like, those kids were jerks.
They're gonna be the same way.
Yeah, they're probably gonna be worse.
Hey.
That's worse than us.
Let's do this example. So the function f is defined by this piecewise function.
That's nice.
What is the value from 1 to 5 of f of x dx? Anybody have an idea of how we're gonna do this?
Well,
Okay.
Oh, no, we don't.
First question. For my piecewise function, are both of these functions on the domain from 1 to 5?
Yes.
Technically, individually, they are not. Together, they are. Because this top function only works for x values that are less than 3. And this bottom function only works for x values that are larger than 3. So I'm going to have to break this up based off, the function of each of the domain of each of those individual functions. So when I split this up, it's going to become the integral from 1 to 3 of that top function, f of x dx, because the domain for that is 3 and below.
No, it's less than
3 and below. So 1 to 3 because my interval started at 1.
x less than 3.
Yeah.
So I thought it would just be 1 and 2. 'Cause the next
No,
one-
we have to assume that they connect. We have to assume that they connect.
It's in the general.
And then the integral, finishing out the interval, so going from 3 to 5 of f of x using that bottom function.
Do we have to assume they connect?
Yes, we can't have a gap.
Why?
Because we can't.
So
That's
wouldn't
not
it
how it
just
works.
be 1 to 5? Oh,
Even if it doesn't touch the x-axis, it's not changing my area.
Yeah, but like even if you just have like this here and then a jump, you could like calculate this area and then add it to this one, even though there's no.
I think right now you.
But I don't have a jump. Like there's going to be some connection in my areas.
Well, there is in this one, but if you didn't have a connection,
Well, I have to have a connection. My domains have to meet up somewhere.
even if there's discontinuity.
Even if there's a discontinuity, yes. Okay, so does everybody see how I split this and why I split it?
Yeah.
Because my interval breaks at 3, I need to make sure my integrals do as well. So we're going to be using f of x based off of the domain interval that I'm currently working in. So from 1 to 3, I'm working with the function y equals 2, right?
Yeah.
And then from 3 to 5, I'm working with the function x minus 1. So when I put it in here, I fill those functions in for the respective f of x. So this becomes 2 dx. And this one becomes x minus 1 dx.
Oh. never
I just
mind.
filled in the respective functions.
Yeah, because you do
And then because we haven't learned antiderivatives yet, we're going to use geometric shapes to approximate the area here. So I know from 1 to 3, my y value holds constant, which means this is a rectangle.
We just assume it's a rectangle.
Well, we know it is because my y value is a constant, which means it's a horizontal line.
Yeah.
And then I know from 3 to 5, this one's going to be a trapezoid.
You might.
It's x minus 1, which makes it a straight line,
They're gonna be
like this. Actually, it would go like this, but still.
How does this help us?
Because it's going to allow me to calculate the areas.
I drew the wrong kind of chart.
Because this is going to have a
So if I
Where's
graph
it at?
those on a map,
y-intercept of -1 and a slope of +1. So it'll look like these. for those particular portions.
Like graph is one graph.
Yeah, absolutely, if that's what you wanted to do. I'm cutting to the chase because you guys can graph on your own if you need that. So now what I can do is use the information I have to calculate the area of each of these respective shapes. So I know for this rectangle, my width down here goes from 1 to 3, which makes it 2. And I know my height is 2 because that's the y value I was holding constant at, which means the area of that rectangle is equal to what?
So that's a square.
Well, yeah, but all
Four.
squares are rectangles. But not all rectangles are squares, correct?
What the?
Then I would do the same information with my second shape. So I know that this height here is equal to 2 because I go from 3 to 5. And then to find my individual base heights, I need to plug 3 and 5 into this function. So 3 minus 1 makes this base 2. 5 minus 1 makes that base 4. And then I just do my trapezoid formula. So 1/2 base 1 plus base 2 times the height. And then I would just calculate it. And we should get an area of 10.
That's kind of cool. I kind of still hate it because then I have to figure out the questions, figure out the shapes.
Well, we only have to do that now because we haven't learned antiderivatives yet.
Which we're gonna do today, right?
Hopefully, if we have time, that's my goal.
No,
But if
it's
we
not.
don't have time, there's no point.
Then we're doing it tomorrow, correct?
You only have
Be
16
free.
minutes left.
I'd go with SRT.
No, you
No.
can't. I have stuff to do in SRT.
Okay.
Like,
Let's see how many more examples we can get to, and if we can get through the next 2, I might stop and finish up notes tomorrow.
Okay, I don't think we're going to.
We'll
So I
see.
think we can get to the next 2 and then stop. Hard stop, cut off.
I just wanted to do it to differentiate.
yeah.
No, it makes
that's
things
not-
easier.
No, we are going to introduce anti-differentiation today.
What? So,
Those
This
functions.
desk is Liam's head.
It makes it easier. You said you didn't want to finish shapes.
I said I don't want to do it at all. You said you
Period.
don't want to find the shapes. If we don't get to that part, we don't have to do the homework. You tell me the homework.
and then we'll do the anti-derivative tomorrow.
Ew.
Yeah,
Yeah, you wanted to do it.
Yeah,
Yeah.
no, I meant the function.
It's okay, they must have looked.
I think you're Anna, freaking proposer.
I
You
We're already
did.
engaged.
I did propose.
Leah,
not
you
have
have
a
a ring.
We both have a ring.
Why aren't you wearing
It's in my car.
it on?
Okay, remember that's my car real quick. You better wear it.
Every day from now on.
It's a paper clip. Gonna turn my fingers green.
Green.
You know, if you write 0 for every answer, you'll probably get the highest score out of any other number writing it for every answer.
Well, yeah, 0 would be the most repeated number. Okay, so the first thing I need to do is I need to figure out how I'm splitting this integral. Anybody have an idea?
Nope, it's a 5
If I finish writing, then I might have an idea.
1 from -5 and 0 and 1 from.
I need to figure out where my interval splits. And it splits at 0, because that's where I have a discontinuity happening.
It doesn't,
But it does.
but it doesn't,
But it does.
but it doesn't really, because it's the same function on both sides.
Mm. Yes, but hold on to that. So my first integral is going to go from -5 to 0,
And that's because.
because that's where my discontinuity happens. Just trust me. And then I will go from 0 to +3. Because that's where my overall integral was ending.
That's because you have to connect.
-5 to 0, 0 to 3. Are we all okay with how I split that?
Yeah.
Okay. So now we're going to reason why we split it. So we're actually going to graph this function so you can see exactly what's happening.
Is it gonna be a big graph or small graph?
It's not huge, no. That was very bad. Okay, so I know I'm starting down at -5 and I'm going to +3. I know when I'm not equal to 0, I'm following that top function, which is the absolute value of x over x. And then when I am equal to 0, it's equal to 0. So I can obviously put that 0, 0 point. Because when x is 0, y is 0. So that's one point that I do have here. I'm going to start at -5, and we're going to plug it in. And we're going to see what our graph looks like when I do that. So the function I'm plugging into is the absolute value of x over x. So when I plug -5 into that, I get the absolute value of -5 over -5. What's the absolute value of -5? 5, which when divided by -5 becomes what? So I can reason that anytime I plug a negative x value into that, it's going to come out as -1 because I'm going to have a positive divided by a negative, right? Which means that I'm going to have a constant -1 y value for this whole interval right here. But Liam, what's going to happen when I plug a positive number into that square root of x over x, not square root absolute value? I'm going to get a positive. For example, if I plug +1 into this, the absolute value of +1 is still +1. And when divided by the same positive on the bottom, I get a +1 answer. Same thing would happen if I plugged in +2. The absolute value of +2 is still +2. Divided by +2 gives me a +1 answer. So now, going from 0 to 3, I have a rectangle that has a height of +1 because that's my constant y value from 0 to 3.
So can you really just like find part of the left side?
Yeah. It will, if it holds constant like this one, which it did. It won't always, but yes.
It's like it's gonna cancel out part of it, isn't it?
Well, yeah, but you have to know the whole shape first.
Yeah.
Okay. So now what I can do is I can find this area, and I can find this area, and I can put them together,
What I'm
right?
saying was, can we just find the area from -3 to -5? It's gonna be flat, isn't it?
If they have the same height. So yes, for this one you could. I'm not going to. I'm not going to on this one. But yes, in theory you could, yeah. Okay, so I know that the integral from -5 to 0 was 5 times, oh gosh. So I had a 5 times f of x dx, which means that 5 comes out front. And I multiply it by the area of that shape. What is that shape? Rectangle that has a base or a length of 5 and a height of 1, but technically -1. So what's its area? -5. So I do 5 times -5, and I get -25 for that first integral.
What?
Don't we
Oh,
add it
okay.
to that?
Because it was a constant 5 in front of my f of x dx.
Then we could just repeat 10 over and over again and get the right answer.
Yeah, absolutely. Thank you.
Get new walls so she can hang stuff on.
Thank you. I appreciate it. Yes.
So polite.
Okay. What was the? I have a phone. What was that? Somebody calling to doing this thing, finish their quiz questions. Right now.
They really
Yeah.
called. Why don't they just sit them down here and, with a note? And
They were being nice. I don't know. Okay. So that was the area for my first integral. Now I need to find my second integral, which still has a constant 5 being multiplied into it because I had a constant 5 there. So now I need to find this area from 0 to 3, and I'll multiply that area by 5 to get the area for that portion. So then I know that's a rectangle. What's the area of that rectangle? 3. My length is 3. My height is 1. 3 times 1 is 3. So 5 times 3 is 15, and then I add them together. So what's -25 plus 15? -10. So my total area for this integral from -5 to 3 for this piecewise function is -10.
That's why I said.
Anybody super duper confused by that?
Not Wow.
Okay. So now what we're gonna do is we're just going to briefly introduce antiderivatives so you're not completely confused when we actually go through them tomorrow.
Are we writing stuff down?
Yes, I would definitely write these down.
But
Well,
should I,
wait, when we
okay, if
do
I have
this-
this much of a page, should I restart?
I would, because you can just continue on it tomorrow.
My God.
When we have this, where we have to draw, will there be like trapezoids and triangles too?
Okay.
Go like 3 lines for that.
So when I'm talking about antiderivatives, I'm talking about the function before we took the derivative of it. So I'm talking about the original of the derivative I've been given. So we have some special notation for antiderivatives and derivatives and integration. So when I'm talking about the original function, so before I took the derivative, I use a capital F. And when I'm talking about the derivative function, I use little f. So the derivative of capital F is equal to little f of x dx. dx here indicates that I've taken the derivative. We don't use y prime here anymore because it doesn't fit with the other notation. Okay, and it's going to get really, really confusing, so we just use the consistent dx here. So the dx indicates that this is a derivative that has an original function that I need to find. So what we're going to practice today is just finding some of those original functions. And then I'm going to show you kind of how to build some of them. So the first one I want to show you, I actually don't have this one in the notes because I don't think it's important.
So the dx doesn't really matter, it's just letting us know what we took.
Correct, that's all it is. But it has to be
Little f
present.
Also tells us that.
Yes, but that dx still has to be present in integration.
Okay.
Okay. So let's practice just finding the antiderivatives of some things before we throw integration into it as well. So let's say, for example, that I know little f of x dx was equal to, I don't know, let's say x to the 4th. And I would like to find what it was before I took that derivative. Okay, so I know that when I took the derivative, I decreased my exponent by 1. So I know when I'm taking the antiderivative, I need to increase my exponent by 1.
Oh, is it 5?
And then I also have to divide out whatever I increased it to. So this one plus 4 is 5. So this should be x to the 5th over 5. So whatever I increase my exponent to has to be divided out to balance it out.
So would it be x n plus 1?
Yes.
Or-
So if we were doing just, I don't know.
Wait, what did you just do?
What do you mean what I just did?
Where did you get those fractions?
I took the 4 and increased it by 1, and then I had to divide out that new exponent as well to keep it in balance.
So if you were to do like quotient rule for that, you would get x to the 4th.
We wouldn't have to do quotient rule because this is the same as 1 over 5 x to the 5th. But yes, if I took the derivative of that, it would equal x to the 4th. Okay? And that's my original function. So if you wanted to write a generic rule for this, we would say that if my little function f of x dx was equal to x to the nth, then f of x, which is my original function, would be equal to x to the n plus 1 divided by n plus 1. That only works when I have just a power function happening here. So just an exponent derivative change.
Okay.
So I'm going to give you another one. You're just going to try it.
We're gonna do it. How do you try?
You're going to do it. I like the enthusiasm. So let's say, for example, I told you that my derivative was equal to,
I'm literally freezing in here. Every day I freeze.
2x to the negative 2.
Not the original.
No, that is my derivative function. I want you to find the original.
Wait, so what about the dx or does that?
Well, so I still use a little f here. These are all different ways they can be written. The 2 just stays there. It's a constant in here. So Deanna, talk me through what you did do.
I know that I need the negative 2 plus 1 over.
So that, what's negative 2 plus 1? And then I divide out that negative 1 as well, right? And what's 2 divided by negative 1? Negative 2, same as multiplying it. So this becomes negative 2x to the negative 1, or you could rewrite it like that. But that was my original function before I took the derivative. How do we feel about that?
I did not as good.
Not as good. So what if I give you another one?
No.
Do it.
So let's say that my derivative function was equal to,
Okay.
1/4 x to the 1/2. And then I wanted you to find the original function. Okay, first things first, what's going to happen to my exponent?
Add 1.
So 1/2 plus 1 becomes what?
1.5.
So 3/2, because we don't like decimals in there or mixed numbers. And then what did I have to do with that 3/2? I had to divide it out of my x, right? But that gets really, really confusing. So what I like to say to myself is I just take whatever the exponent is, I flip it over and I multiply it into the x. So instead of dividing by 3/2, I'm going to think about it as multiplying by 2/3. And then I just simplify, and I get 2 over 12 x to the 3/2, which I can reduce to 1/6 x to the 3/2. Are we all okay with that?
No.
Anybody super duper confused by that? No, we're okay. So then what if I give you a different one? Let's say that my f of x was equal to negative sine of x. And I wanted to know my original function.
Cosine.
What do I take the derivative of to equal negative sine of x? Cosine. There is no magic trick here. You're going to have to know those derivatives forwards and backwards.
So that
Like,
was just the
got
same.
rid of
Yeah,
one,
that's
it's the
easy.
same thing.
But I also feel like it could get way harder.
Oh, it does. Like, for example, I'll throw this one at you.
No.
Just
That's
because
it?
he said that.
Yeah.
That's
Figure
it?
out that.
Well, these are just basic antiderivatives, yes. Say that was my derivative function.
Oh.
What would be my original? Ooh, I heard it somewhere. What is it?
I don't know.
It's an inverse derivative, right? So I would have to go back to where I did derivatives of inverse functions, and I would realize that that is the sine inverse. These are also ones you're going to have to know forwards and backwards.
What?
That are gonna be on our cheat sheet.
Yes, they can be on your cheat sheet. Okay, so these are just basic antiderivatives. Of course, when we get into like product rule and chain rule kind of stuff, it gets a little bit more complicated.
Did you not see that?
I saw.
Because Miss Shepard tried to.
It was, I know, I just saw her drive by.
What is she doing?
I don't know. Okay, so we're gonna go ahead and stop here. Your homework is